Well, hello. This is Donna, and welcome along to my final project. I will be discussing why an upgrade to the current pneumatic tube system can benefit Lancaster General at the Suburban Pavilion, Women's and Babies Hospital, or WBH, and the Ann B. Barshinger Cancer Institute, or ABBCI. I will do this by providing background and history on the tube system, describing current use and pitfalls, presenting my research and brainstorming process, pitching the pitch, outlining resources, and connecting it to the framework of innovation. But first, a little background. The Suburban Pavilion was built in 1994 as a freestanding outpatient facility. It provided lab drawing services. However, all samples were couriered downtown to the mothership for processing. Women's and Babies Hospital, or WBH, was completed in 2000, and as a hospital, was required to have on-site lab processing. The tube system, constructed for use within the hospital, was expanded to connect the two facilities. ABBCI was completed in 2014, and an additional branch was added to connect all three facilities. The WBH tube system has 11 stations connecting the facilities. They can be as simple as this one that services the OR and NICU at WBH, or a double system like the one in the lab at WBH. The carriers look like this. Notice they are not transparent. To send a sample, it is placed in the carrier, the destination is selected on the control panel, and off it goes, and the problems can begin. If the carrier is stuck along the tube path, the carrier will return to the send point. If there is a carrier at the destination point that has not been received, the sent carrier will return to the send point. When a carrier reaches the destination, an alarm sounds. It is easy to just turn it off and leave the carrier where it is. Or, the send is successful, the carrier is removed from the station and tossed onto the counter with other carriers that could be empty or not. Remember, the carriers are not transparent. This outlines some of the ways samples get misplaced and are not processed before they need to be redrawn. Moving on to my research, I went directly to google.com patents, where in less than half a second I had over 19,000 results using the search tracking samples in a pneumatic tube system. As I explored the patents, I selected 3 and found it much easier to compare them using the United States Patent and Trademark Office external link provided on the site. The patents I selected all involve upgrades to the tube system for more efficient tracking of samples. They all have system control modules. One has the ability to identify carriers by color-coding them to associated color-coded destinations. Another offers additional database and archiving capabilities. The last adds ID tag readers at send and receive stations to confirm transports. I found this one interesting. My own personal innovation to increase efficiency and safety using the tube system involved utilizing our ID badge. It appears someone has already identified this. Incidentally, a colleague informed me of a solution to track samples that is currently in use at the Duke Street location. Armed with this information, I performed a quick SWOT analysis on my top 3 options. I disregarded the option to use color-coded carriers. With 11 stations servicing our facilities, that did not seem viable. The first option is already within use in the WBH system. There is opportunity to increase reporting and alarm systems, and the obvious threat is pulling out containers and letting them lay. The second option, with additional ID badge tracking capabilities, would require funding and system downtime, but offers a very high compliance rate for staff, requiring a badge swipe at send and receive. This would generate tracking information for review when necessary. The third option, though already in use, requires additional time for staff to complete the workflow, which could result in non-compliance. Organizing my research in this fashion made my selection fairly straightforward. And so, here's the pitch. Working in the field of healthcare is a demanding job. The workflow each day is very fluid, and change can be the standard 24/7. To ensure that safety, efficiency, and top-notch patient care are provided each day, systems must be in place to ensure that staff can perform their daily tasks quickly and correctly. An upgrade to the current pneumatic tube system, which connects WBH, the Suburban Pavilion, and ABBCI, would provide additional information on each sample that travels in the tubes. This would be accomplished by adding badge tagging so each sample so it can easily be tracked anytime within the system. A required badge swipe at send and receive will provide staff with up-to-the-minute tracking information. The database and archiving capabilities can identify problems and opportunities for improvement. The upgrade does involve a cost, which can be offset in reducing the amount of additional work when studies need to be redrawn and utilizing reports to increase efficiencies. This innovation is user-friendly and does not add additional time to workflow or the need to reference various work lists to confirm location. Resource-wise, there is an obvious need for money to fund this upgrade. It will require a capital request to LGH leadership. Other resources are actually minimal. All employees have an ID badge, and training would be almost non-existent. From the perspective of the framework of innovation, I would classify this as an incremental product innovation. The innovation will provide an existing pneumatic tube delivery system, which is incremental, but I believe it can also be a product innovation due to the improvements the upgrades will make with respect to new software and increased user-friendliness. As a healthcare organization, one of our purposes is treatment, and this innovation will increase quality, safety, efficiency, and outcomes, though it comes with a cost, which can be offset by increased efficiency. Providers, healthcare workers, and patients can experience increased satisfaction due to this increased efficiency and quicker outcomes. The delivery of care will benefit from this innovation. As I noted in my reflection paper, my eyes have been open to the science of innovation, how it all begins, and the process behind how an idea goes from just that, an idea, to a process, product, or workflow that has effect on many. Here are my references, and thank you.